This video is going to be about getting literature so that you can do your job better in the field. It used to be in our classes that we would pass out literature to the technicians in the hard form, but now everything is digital, so things are available digitally. I would encourage all of you to get either the Carrier Service Tech app or the Bryant Service Tech app. These apps are available to everyone, and you can get them for either the iPhone or the Android. By getting these apps, you have access to all of the Carrier and Bryant technical literature that you'll need to do your job in the field. This is the front page of the Carrier TechLit app, and here you can type in a serial number or a model number to find the unit. You can also scan a barcode that is usually on units or a QR code that is on the unit. We want to use the literature lookup, and so we're going to look up literature for a particular unit. We have chosen the Infinity Variable Speed Heat Pump, model 25 VNA 360030. And we are going to, once we get that literature selected, it will show us the unit and the model and serial number that we have selected. And we are going to select here all literature, which will bring up every piece of literature that is available for this particular unit. When we have selected all literature, as I said, everything that is available for this unit will be brought up, as well as bulletins that will give us certain information regarding any reworks or any issues that have come up with this unit. We have chosen to bring up the service manual, which is what we will need to do technical work. Has all the service information, ohms on the compressor, resistance of all the sensors, voltages, volts DC that we should be seeing on the system. One of the nice things that you can do with the literature is you can email it to yourself. This is helpful in building your own library of technical information. By emailing this document to your tablet or phone, you can build your own technical lab, and whenever you're on a particular unit like this one, you can bring it up whether you have Wi-Fi connection or not, and be able to download or look at all the information you need to complete your job. Let's look at another example of a troubleshooting guide that we may need. This is for a variable speed modulating gas furnace. And this is the troubleshooting guide for that furnace, which gives us all of the alarms and fault codes that we might see and how to troubleshoot them and how to fix the situation. On the first page of the troubleshooting guide, you will find the various codes for the lights. All of your furnace boards are going to have lights on it, which will give you an idea of what is going on. The lights will usually flash short and long flashes so that you'll be able to determine what the fault code on the furnace is. When you begin the troubleshooting procedure in one of these technical manuals, it's going to start off basic and ask you what the amber LED is doing, or the green or the red. And depending on what you answer the question, whether you answer the question yes or you answer the question no, it's going to tell you which step to go to continue the troubleshooting guide. So in this particular case, the amber light is blinking rapidly without a pause. And so you answered yes, and so it's telling you to go to step 3 of the code that is flashing for that particular fault code. This particular furnace is showing a fault code of 41, which means that it is a blower motor fault. So 41 is indicating that the blower motor is not reaching 250 RPM, or the blower has failed to communicate to the modulating furnace control. It goes through some basic things like, is the blower wheel rubbing against the blower housing, things of that nature. Does the blower wheel turn freely? And then it's going to do the same thing that we said before. Either yes or no answers will lead you to a particular step that you need to go to resolve the issue. In order to troubleshoot fault code 41, we're going to continue through the manual, And one of the calls that we get quite often, because these are ECM motors, the technician will tell us that the ECM motor has 115 volts or 230 volts to it, and it's not running, and they don't understand what's going on. So in the troubleshooting guide, yes, it does ask you if you have the line voltage to the blower motor, which is an ECM motor, but that does not mean that the motor is going to run. The line power is to power the electronics in the back end of the motor. So in order to make the motor run, you need to have DC voltage commanding the motor to run and commanding the motor to stop. This is where these troubleshooting guides come in handy, because you need to know which wires to check and what voltage you should see. So if you're supplying voltage to the DC ECM motor on particular wires, such as red and green, your motor should start running. And in this particular case, you're looking for a 12 volt DC supply. And then it also gives you voltage for the yellow and green wire. And those voltages usually will be a 0.2 volt DC to a 1 volt DC. So you see how important these troubleshooting guides are, because without them, you would have no idea what the DC voltage is you should be seeing on these wire leads going to the motor. On your modulating gas furnaces, you will also have an inducer motor that is an ECM motor. If the ECM motor for the inducer is faulting, you will get some type of a code, like code 42 in this particular case, that tells us that we have an inducer motor fault. Like with the other troubleshooting, they will ask you if you have 115 volts to your inducer motor. This would be the first stage of troubleshooting that would tell us that the inducer motor is powered and is ready to run when it receives signals from the control board to run. Let me point out one other thing here. They ask you on this troubleshooting guide, are all pins and wire leads intact at the connectors? If you're using fat pins on your voltage meter and trying to shove those into these pins, you can do a lot of damage. Many times the fault is not with the inducer motor and the fault is not with the control board. It's with the plug, that the pins in the plug are not making contact. So always check your wiring harness to make sure that the wires are seated correctly and the pins are making good contact in those plugs. Then, as with the other inducer motor, the pulse width modulation line on the ECM motor is what tells the ECM motor to run. And you need to know what voltages you need in order for the inducer motor to run. So you want to run a component test, turn the switches on to make sure that the inducer motor is going to be running. And you notice here that when the motor is off, you should see 2.0 to 5.0 DC voltage. And when it's calling for a medium speed, you should see 9 to 13 volts DC. Again, in order to properly troubleshoot these ECM motors, you need to know what kind of DC voltage you're seeing on the motor. Another thing, with some ECM motors, you have an ECM RPM feedback line, which gives a feedback signal to the control board to tell the control board that the inducer motor has received the signal and it is running. So in this case, on the orange and brown wires going to the ECM motor, you should see 15 to 17 volts if the motor's off, and 12 to 14 volts DC if the motor is commanded to run. So again, these troubleshooting guides are very important to know the voltages that you should be seeing at these motors, to properly troubleshoot them, to see if the control board is sending these voltages out, if it's getting through the wiring harness and getting to the motor, or if the motor is getting the voltage but not running. So this will show you what the component is that you need to replace in order to get the inducer motor running again. Then, to complicate things a little bit farther, on modulating furnaces, you usually have a gas valve that is modulating. And so you're going to have a fault code for a gas valve fault, that the gas valve is not responding to commands from the control board. So once again, in the troubleshooting guide, it's going to give you voltages that if code 35 is flashing, you need to check your DC voltage. In this case, you have 24 volts AC that is going to the gas valve. And so you need to check for the 24 volts that you would normally have to the gas valve in order to energize the valve, like the 115 volts does to the ECM motor. Then if that is okay, then you check your DC voltage. In this case, your plug the yellow wire and the green wire, and you should have 4 volts DC across that. And then by going down through the troubleshooting guide, there's other voltages. And again, it will tell you whether you have voltages at these different points, what voltages you should be seeing as you troubleshoot this modulating gas valve. Now, normally in the appendix of the troubleshooting guides, you will find things like this, like your pressure switch make and break points, which is very important information for you to troubleshoot a furnace. They'll also give you diagrams of how you should set up your slope gauge or magnehelix or whatever gauge you're using to read these things. And then you'll also have information like your microamperage on your flame sensors, what you should be reading there, ohm readings on your hot surface igniters, gas valve ohm readings, and possibly, if your furnace has it, a power choke inducer. So you'll find all kinds of good information in these troubleshooting guides to help you troubleshoot properly.
Go to arefco.com for more videos. Like, subscribe, and check back every week for new videos.